Today in this lesson, I will explain the how to derive the formula of radius of hydrogen atom. This is the part of Bohr atomic model. Okay, now initially let's suppose we have a nucleus having charge of plus E and it is surrounded by an electron. So whenever this situation is there, so it start revolving with the force F, and this force is called electrostatic force. And remember that because of this electrostatic force, so electrons start revolving around the nucleus. And so whenever we are talking about the revolution or revolving, it means there is another force that is called centripetal force. So two forces are balancing each other. That electrostatic force is balancing the centripetal force. And if we do remember the formulas of electrostatic force and the centripetal force, these are kze into E upon r square equal to mv square upon r. Okay, now here the k is the Coulomb constant and it can be calculated by the formula 1 upon 4 pi e naught. And when we talk about the z, z is atomic number. This is a symbol of atomic number. E is the charge on electron and proton. Both have the equal charge. R is the radius of hydrogen atom. Basically, we are driving the hydrogen atom radius. M is the mass of electron, and the last V is the velocity of electron in the shell. Okay, now these are the symbols we will be using to drive this formula. Okay, let's move forward here. The first simplification we can see here, if you see the R, the this R basically, this R and that R. So both can be simplified by this way. So this r will be cancelled by that. So after the cancellation, what we get k z e square upon r equal to mv square. Okay, now this is the first simplification. So let's suppose if I just mark this equation as equation a, because here we will just introduce another formula that according to Bohr's, the angular momentum is equal to integral multiple of h upon 2 pi. Here this integral multiple means this n basically could be 1, 2, 3, 4. Basically it is a symbol of principal quantum number. So it basically represents the shell number. If you do remember the postulate of Bohr model, so you easily remember this. Okay, now what will be the formula of angular momentum? The formula of angular momentum is mvr equal to nh upon 2 pi. So here why we are using this formula, because we will just use the this formula and we will just put in the equation a. So how we will put this formula in equation a? So I just substitute the value of v, that would be nh upon 2 pi mr. What I did, I just moved this m and r toward right hand side. So it will become v equal to nh upon 2 pi mr. So now I can put this equation in above a equation. So what will happen now? I can write in this way. So what I did, I just written nh upon 2 pi mr in place of v. Okay, after this, now what I will do, I will just open this bracket by this square. So what I will get, I will get this. Now here some simplification can happen. You can see the m is cancelling. This m can be cancelled from this m, and this r can be cancelled from that r. So after the cancellation, what we will get, kze square equals to n square h square upon 4 pi square mr. Okay, now this is the just second last stage where we can get the formula of r. Okay, if I just move this r toward left hand side and this whole value toward right hand side in place of this r, so we can get our formula. So this is the formula, r equals to n square h square upon 4 pi square m k z e square. Moving forward, this is our formula, r equals to n square h square upon 4 pi square m k z e square. So if we put all the values now here, we have some values. For h we have the value 6.63 exponent minus 34 joule sec, and the value of pi we know that 3.142. The mass of electron is also constant, 9.11 exponent minus 31 kg. Value of k is 9 exponent 9 Newton meter square upon Coulomb square. Z is 1 for hydrogen atom. We are driving the radius of hydrogen atom, so we will put Z equals to 1. And E is the charge on electron, that is 1.6 exponent minus 19 Coulomb. Okay, now if we put all these values, so we will get after the simplification this thing r equal to n square into 0.529 exponent minus 10 meter. Okay, now you can see this one is very small value, so we can do another thing here. If we just use another prefix, or you can say of units, that 10 exponent minus 10 meter is equal to 1 angstrom. Basically, this is the multiple unit for the length we can use here. So then our radius formula will becomes n square 0.529 angstrom. So this will be the most simplified formula of the radius. Now let's suppose we want to calculate the radius of first orbit. So for first orbit n will be equal to 1. So what we have to do, we have to just put the value of n and we can get the radius. So now I'm putting n equal to 1. So what I will get, r1 equals to 1 square into 0.529 angstrom. So after simplification I will get 0.529 angstrom. So similarly I can calculate for second orbit. So n will be 2. So r2 equal to r2 square into 0.529 angstrom, and after the calculation I can get, or everyone can get, 2.11 angstrom, the radius of the second orbit of hydrogen atom. So this was the formula and this was the calculation. Thank you, class.